Hello my dear students, welcome to my channel Let's Learn, and today I will discuss about the binary search. So binary search is a type of search in which we need a sorted list. Means the list in which we have to perform the search should be sorted. Otherwise the search will not work properly. So first we go for the algorithm of the binary search, and then we will see the program in the Python language, and it will help you in your examination also. So now moving through the algorithm without wasting the time, we will go step by step in order to understand the algorithm of the binary search very effectively. So now the first step of the binary search is that we have to read the element, or we have to take the input of the element which is required in order to search the element. Means the user will enter the element that you have to search. Now in the second step you will have to find the middle element of the sorted list. Means the element that is on the middle, means the highest position, the lowest index is 0 and the highest index depending upon the length of the array, and you will have to find the middle element, and then compare the middle element to the element that you will have to search. And if the middle element is equal to the element to be searched, then what will happen? Then the search will successful, and then simply display the given element is found and terminate the function or terminate the program. But what if there is no any proper match? Then what we will do? So we know that the list is sorted, and in the sorted list, if we have a element that is greater than the middle element, then what will happen? The element will be found the rest of the part of the list that is greater than the middle element. And if the element is smaller than the middle element, then what will found? The item will found in all the elements that are smaller than the middle element. So from this place onward we will divide the list or the array in two parts: the elements that are greater than the element to be found, and the list in which the elements are the smaller than the value to be found. So we will do it again. Find the middle element of the rest of the array, and again we will compare the middle element to the value to be searched, and similarly repeatedly the process will goes on until we find the element. And if the element is not in their list, then what will happen? Then we will simply display a message that the element is not found in the list and terminate the function. Now as you can see in the example, this is a pictorial representation of an example. There is a list given, the list is sorted, and you can see that here the element is 1 2 3 4 6 7 and 9, and the element which you have to search is 6. Now find the middle of the element. The middle of the element according to the pictorial representation is 4, because the three elements is here, and the three element is this side, and the fourth is the middle element. Now compare the middle element with the list to be searched, or with the element to be searched. Now here you can see that the middle element is less than the element to be searched. Then what will happen? It is easily known or the shown that the element will be found in this part of the array. So we will simply discard this part of the list. Now moving forward, we will have to again find the middle of the element. Now here from these three elements, 7 is the middle element. Compare the middle element, and here you can see that 7 is greater than the element to be searched. Then what will happen? The list will be again break up in two parts. The first part that contains the element that is greater than the middle element, and the second part that is smaller than the middle element. And then you can simply discard the one part of the list. Like in this, we can discard this element, and now we have only a single element, and this is the middle element also. Then what will happen? This element will be matched to the item to be searched, and here the match is found. So with the help of this diagram, it is easy to understand that how binary search will work. Now I will show you that with the help of a program that is in Python, that how binary search will work. In this program, I will show you that how you can implement a binary search in Python language. So in the starting, in the line number 1, I had taken a list that contained few items, and as you can see that the list is already sorted. But if you are taking list as an input from the user, what you can do, you will have to apply the sort function before starting the binary search algorithm. So as the user entered the values, so that you are not sure about the values, that the list is sorted or unsorted. So now start with the function. As we all know the algorithm, we will have to find the mid of the element, and we will have to compare the mid element with the element to be searched, and if the match will happen, then we will say that the item is found, and if the match will not happen, then the few rest operations or the few rest steps that we will have to take. And now we will implement. First of all, a variable is taken named mid, and starting it is assigned 0 in order to remove the garbage value from the mid value or the mid variable. Next we have a value low. As you can see in this diagram, if this is a list, or simply you can see if this is a list here, then 1 is at the 0 index, and the index of this last value is equal to length minus 1. So the low value is the starting index and the high is the last index. So initially I had assigned the value 0 to the low because the first index is low. Then I had count length of the list and then assign the value that is length minus 1. And also I had taken a flag f and it is assigned 0 initially. If we found the element, then the flag will 1. If we will not found the element, then flag will still 0. So now in line number 7, what happened? We are taking the element as an input from the user, this particular element to be searched from the program or from the list. Now here I had applied the while loop. The while loop will run until the low is equal to or less than high. When the low is starting greater than high, then the program will must stop. So the while loop will run until the low is equal to or less than high. So in the line number 9, I had calculated the mid. The mid is equal to low plus high and divided by 2, and in the mid we have the value of the middle index, the index that is on the mid position. Now here is one point to note that the mid is the index, middle index, not the middle value. This is the index of the middle element. So now in the line number 10, there is a comparison that if list middle is greater than element, then what will happen? High is equal to mid minus 1. Means if this is the list and here is the mid element and the element that we have to search is greater than element, then the list is sorted, and we all know that the list in this part is smaller than the mid and list item in this part is the greater than the element, then what will happen, we will have to implement the binary search algo again in rest of the this part, and the upper part of the list will be discarded, and the high will remain at its position and the low, which is at the upper position, will be moved downward, and the value of the low is equal to mid plus 1. So now having a look on the program, now as I am comparing, high is equal to mid minus 1, and similarly when the mid value is less than element, then low is equal to mid plus 1. And now moving forward, simply in the else element, what will happen, here we are printing that the value is found and the index of the value is mid, and assigning the flag is equal to 1, and here if the value is found, there is no need to execute the loop, and here I had simply applied the break statement. And if the value is not found, then what will happen, the flag will remain 0, as in the line number 4 we had assigned 0, so it is simply said that if the flag is equal to 0, then the value is not found. So the essence of the program is to understand that how the value of the low and high will updated, means if the mid element is greater than mid, then what will happen, this value is here, and if the element is lower than mid, then what will happen, this is here. Now moving to the program, you can see I had entered a value 4, and you can see the value is found and the index of the value is 2. So in this way you can implement the program in the Python language. Thank you.